Hi everyone. Now we're going to continue our talks about how automation can help you achieve sustainability targets. First, let's take a step back and think about the network operation lifecycle as a whole. Sustainability should be an integral part of it. It shouldn't be an afterthought. And this is something that we've been working together with the Crosswork automation team on. If you remember from Ran's session from yesterday, we are breaking things up into visibility, insights, and action. And we're going to talk a bit about how sustainability fits into each of those buckets. So starting first with visibility, the previous session I talked a lot about how we can provide visibility into different sustainability KPIs. And that involves collecting, storing, and also, of course, visualizing those KPIs over time. And those KPIs can be quite diverse in their own way. So you can look at power consumption of a device, you can look at carbon footprint, you can look at carbon intensity for particular sites and locations, maybe even the energy mix. Is it coal, is it hydraulic power, and so on. And of course, energy cost. Now, once we have access to all of this data, all of this information, we can analyze it in order to gain meaningful and hopefully also actionable insights. So we can we don't want to look at metrics like power consumption just on their own. We want to also understand the context. So if we look at a particular device and we measure the power consumption, so what does that mean? What capacity does this device provide? So then we can derive more composite metrics and say things like, hey, it consumes this much power per gigabit per second of installed capacity. And then comes the usage. So, okay, you have all of this capacity that is installed, but are you actually using it? What traffic is being carried by that device? So then you can think of how many watts per gigabit per second of carried traffic, to give some examples. And of course, not looking just at the device level, you can look at the path level. So you can say, hey, what is the power consumption per segment routing policy? Or even what is the carbon footprint per VPN? And the next session we'll talk to that a bit. And then it's also possible to do some analysis and understand if there is any anomalies in terms of sustainability KPIs. So is there a significant deviation for the power consumption of a device compared to its past or compared to other similar devices? And then finally, of course, which will be more the focus of this session, how can we design more energy efficient networks? And that, more on that in a bit. So looking at the action part, Eric gave some examples as to what optimization objectives can be set and what are the levers in order to be able to achieve those objectives. So very quickly, one example is the ability to selectively shut down a set of components based on observed usage patterns. Or maybe change the power and performance modes. A hint, we'll be looking at that in this session a bit more. And then finally, moving services onto greener pastures. I have to make that joke, greener paths. So let's zoom in a bit on network design and planning. So in order to operate efficient networks, you need to have the right foundation. And that foundation comes from having properly designed and planned them in the first place. So in order to do that, you have to be able to answer a bunch of hypothetical questions. So it's things like, what would happen if my traffic grew by 10%? What would be the impact? What would happen if any link were to fail? What would happen to the utilization? So once you are able to answer those questions, and in order to do that, you need some form of simulation engine to be able to actually understand the impact of things that are not happening at this moment, but may happen in the future. So once you have that foundation, then you're able to actually optimize your network design and planning. So typically, objectives would be minimize the network equipment capital expenditures as you're looking at your future plans. And for that, you can impose a set of optimization constraints, I don't want the utilization in my network to exceed 50% under steady state and 80% under any single link failure. So constraints like that, maybe some things on performance, like bounds on end-to-end latency. And then looking at sustainability, we can additionally introduce sustainability objectives. And I think a key word here is additionally. So it doesn't have to be either or, but we're able to also evaluate such constraints and objectives, and then evaluate potential trade-offs or actually even synergies in a lot of cases. So looking at projected traffic growth, you can say, what would be the power consumption or the carbon footprint in order for me to meet that growth? And then what type of equipment should I actually select to optimize that? There were quite a few mentions of the routed optical network architecture today, so I think it's very interesting to think about benefits of optical pluggables also compared to transponders in terms of power consumption. So analysis like that, or you want to deploy a new site, and you want to find the optimal location. So maybe some locations are served by different energy sources. But in order to be able to do that analysis, you need the right tooling. Enter WAE. As probably quite a few of you here know, WAE is an industry-leading planning tool. It has been around for many, many years. And it came to Cisco through the Caradan acquisition. So how does it work? So first of all, it needs to build an abstracted network model instance. So that contains the information on the topology, information on things like segment routing policies, RSVP LSPs, abstracted VPNs, even optical layer information. And of course, a key ingredient to it is what we call traffic demands. So these represent the end-to-end traffic flows. So we need to see what that is in order to then be able to simulate how traffic would reroute under different scenarios. So then at the bottom, you see a visualization of a topology and then the sets of functionality that it offers on a high level. So of course, you can visualize, you can simulate different scenarios, you can analyze the impact under defined sets of failure scenarios and then see what would happen. You could do capacity planning, and then you can figure out where you should add capacity to meet those constraints while minimizing costs, for example. And then finally, a set of optimization tools, things like IGP metric optimization, segment routing path optimization, and so on. So the beauty of WAE, in my eyes at least, is its extensibility. So at the top, you see how you can create a new LSP through the GUI. But you don't need to do it through the GUI. You could also write a script. So we do have a very rich set of APIs. The lower level is what is the RPC API, and then we have a higher level API, what we call the OPM API, which is more Pythonic. And then it allows you to write your own scripts and do whatever you want. And this is something that we've done in this POC, and Julia will talk about that a bit more. And another key part is that, of course, we have our schema that defines the attributes and the objects that we understand and we simulate, but you're not confined to that. you can actually go and extend that schema so you can have user-defined attributes and user-defined objects as well. Yeah. So going back to sustainability, in order to be able to achieve sustainability goals, you would typically ask a series of questions. So first of all, how can I reduce the energy consumption in my network? What would be the recommendations? And then once we have those recommendations, like if I went ahead and made those changes, what would be the impact? Because it's not only about sustainability, there are other aspects in play here as well. And then finally, assuming that I do want to go ahead with that, what steps should I follow to actually go ahead and provision those recommendations? So in this POC, in a bit, we are going to be using WAE, some add-ons, so the custom extensions that we spoke about a bit more, and also Crosswork Workflow Manager together with NSO. And maybe you saw some of the Crosswork Workflow Manager sessions earlier. I think there are also some following. So with that, let's jump to the demo, and I'll hand it off to Julia.
Thank you, Eleni.
Thanks.
Okay, so my name is Julia. I am TME for Crosswork Automation. And in this demonstration, we want to show an early prototype of a closed-loop automation solution for sustainability. And what we want to show is how our applications, our Crosswork applications, can interact between each other to provide this objective. So starting with the demonstration here, we can see that CNC already collected the network topology information as well as all the traffic engineering information. And CNC provides a RESTconf API to export this network information into a network model format that is understandable by WAE. So if we go to WAE, we can see the representation of the same network model, including nodes information, LSPs information. And here we also populated the demands that represent the traffic that is routed throughout the network. So then if we go to the nodes table, notice that it is important to collect the vendor, model, and OS information, because this information will be used to identify which devices support the power profile capability. And WAE provides a large set of Python-based APIs to create extended functions that are also called add-ons. And this is how we build this power-saving add-on. So it includes 3 steps. The first step is the recommendations. And here, the tool will provide to the operator some energy savings recommendations based on the current actual network model information. So once this first step is executed, it will produce a new plan file. And in this plan file, it will also create a new table. So we will open this new table. It is called Sustainability and Device Capabilities. And in this table, the operator will be able to see the mapping between the vendor, model, OS information, and the capabilities of support for sustainability. So in this case, the tool identified 2 specific device models that support the NPU power profile, and the recommended value it is to set to low. It also provides a short description on why this low value is important. And if we go back to the nodes table and open the corresponding vendor, model, and OS columns, we will see that the tool also did a match of this information with the device capabilities table and identified that one device in this topology, the R13, supports the NPU power profile. And actually, its value is set to high, which is a not recommended value. So then the add-on will also generate a report. This report is called Power Saving, and it will include the recommendation summary, where it identifies that one device is using a non-optimal energy management setting. And in the details table, it provides the details of this device, including its current value and the recommended value that should be set to low. So then we also can monitor in CNC what is the current power consumption for this device that is using the high profile. So we can see that it is consuming 254 watts for the input power and 204 watts for the output power. So next, because in order to change the power profile, it will be required to do a reload of the device. So the operator may be interested in seeing what will happen to the network, what will be the impact during this reload. So in this model, we can help to identify what demands are using this device. So we can see that 2 demands are routed through the R13. And if we filter to the corresponding LSPs, it finds two SR policies that are associated to those demands and are routed through the R13. And this information can also be validated in the CNC. If we go to the T dashboard in the CNC, and we select the two SR policies, and then visualize the IGP path for them, we can confirm that they are routed through the R13. So then back into WAE, we will ask WAE to do this simulation. So for that, we will execute the second step in the add-on, that is the impact analysis simulation. And here we can set a maximum interface utilization, for example, 75%, which means that during the simulation, if any interface goes above that threshold, it will be considered a violation. So then after the second step is executed, it will produce a new plan file. And in this plan file, we can see that traffic was already drained out from this device because it was put into maintenance or avoid transit mode. And if we check our two demands, so we can see what happened to them. They are still routed, but they are using a different path. Now they are going through the R6. And if we filter to the corresponding LSPs, we can see that two SR policies are still active and routed, and they are using the path through the R6. And also all the links are showing green color, what means that utilization is lower than 50% in this setup. So this second step will also produce a new entry in the report, that is the impact analysis summary. And it is showing that 0 interfaces are crossing the threshold that we set to 75% of utilization, and also 0 LSPs are unrouted in this network model. So then if the operator is comfortable with these results, the next step would be to do the provisioning, so the actual changing of the power profile. And for that, we will execute the third step in the add-on, that is the deployer. And here, the tool will communicate with a workflow manager via RESTconf API, and will pass as an input argument the name of the device that was identified in the previous step, in the recommendations step. So once this add-on is executed, it will trigger the workflow in the workflow manager. So let's switch now to the workflow manager UI. And here, if we do a refresh, we will validate that the workflow was triggered, and it's running, and the first step in the workflow is already completed. So that means that the device was already put into maintenance mode. And we can validate this in the TE dashboard in CNC. If we show the IGP path for the two SR policies, we can see that they are using the path through R6, which means that behavior is exactly what was predicted by WAE. So then we need to wait for the next step to be executed in the workflow. That in this case, it is to change the power profile to the low value. So we can see that it is running. If we do a refresh again, we can see that the step is completed, and the next step in the workflow is to execute the reload of the device. So we can also validate this in CNC, in the topology UI, that the device is being reloaded, because we can see, for example, in this case, the links are showing degraded or down state. And in this setup, the reload of this device will take approximately 5 minutes. So we can monitor the progress of this task through the workflow manager. And once it is completed, we can see the links are back to healthy state in the topology UI. So after that, we still need for the additional steps in the workflow. So if we click refresh, we can see that the device is now removed from the maintenance mode in order to permit, again, that the traffic goes through its device. So in this case, if we validate in the TE dashboard and select our two SR policies and visualize the IGP path, we can see that they are now using, again, the original path through the R13. So next, we just ensure in the workflow that all steps are completed. So we validate all steps in the workflow are completed. And then that means that the power profile was successfully set to a low profile. So we validate in the power consumption dashboard. We wait for the next collection period. And we can see that the power was decreased. The input power is now 212 watts, and the output power is now 152 watts. So it means that in average, it decreased around 50 watts for this device after we changed it to the low power profile. So with that, we completed the demonstration. And now back to Eleni.
Thank you, Julia. So this is the last slide, don't worry. So summing up, we showed how automation can help you achieve sustainability goals using some of our products and extensions. And at the bottom, you see the degree of automation increasing with increasing automation towards the right. So you can think of it as a journey. You don't need to do everything all at once, but there are some steps that can be taken. So for example, here, the first step, you can see that there is some analysis in that respect, but a lot of it is manual, and you see a lot of user interactions with the WAE side. But then you could and there's the separation with respect to how those recommended changes are provisioned. Here now we're automating all of these manual back and forth through a script by having a WAE add-on, but there's still no integration with workflow provisioning aspects. And then finally, you could have a more holistic approach where everything is more integrated and both the analysis and optimization is automated, and also there's integration provided with the workflow. So thank you very much for your attention. We're looking forward to hearing questions from your side, and also please do reach out afterwards if you'd like to discuss any sustainability aspects. So thank you.
Thank you, Eleni. Thank you.